If you see a rock shining like this, stop. Not because every shiny rock is worth a fortune, but because that flash may be telling you something. A hidden crystal, an unusual mineral, a strange chemical reaction, or a geological process that took millions of years. Most people see a rock and keep walking, but sometimes, the moment light hits the surface, the entire story changes. Some stones shine because of ancient shells, others because of microscopic structures hidden inside the crystal. And one of the stones on this list can contain several different colors inside a single crystal, recording changes that happened deep inside the earth. Today, we're counting down 10 rocks and minerals that can reveal extraordinary color and shine, what creates their beauty, where they form, and why some of them are prized by collectors around the world. Starting with number 10. Number 10, Peacock Ore, purple, blue, gold, green. At first glance, Peacock Ore can look as if someone spilled a rainbow across a piece of metal. The name is commonly used for colorful bornite, a copper-bearing sulfide mineral. Bornite forms in copper-rich geological environments, often where hot, mineral-rich fluids move through fractures deep underground. When its surface alters, thin layers can produce spectacular rainbow colors. But there is an important warning. Not every specimen sold as Peacock Ore gets its color naturally. Some chalcopyrite specimens are treated to create a stronger rainbow effect. So color alone does not prove rarity. But if a dark, metallic rock suddenly flashes blue, purple, and gold, it deserves a closer look. Because the next mineral produces an even more dramatic color against an ordinary background. Number 9. Vanadinite. Imagine breaking open a dusty rock and finding clusters of brilliant red crystals inside. That is vanadinite. Its crystals can appear deep red, orange red, or brownish red, and some of the finest specimens look almost too vivid to be natural. Vanadinite forms in the oxidation zones of lead-rich mineral deposits. As groundwater interacts with existing minerals near the Earth's surface, chemical reactions slowly create new crystals. Famous specimens come from Morocco, where vanadinite can form spectacular clusters. Its intense color and crystal shape make it highly popular with collectors. And it contains vanadium, an element with important industrial uses. But the next stone does something completely different. It can look pale and almost featureless until you move it. Number 8. Peristerite. Peristerite is a lesser-known member of the feldspar family, and at first glance, it may not look special at all. Pale gray, white, almost ordinary. Then the angle changes. A soft blue glow appears beneath the surface. Move the stone again, and the color can fade away. This happens because of microscopic internal structures that interact with light. The stone is not producing light. It is redirecting it. That blue sheen can appear from one angle and disappear from another, which is why experienced collectors rarely judge a stone from a single position. Sometimes, a slight change in light is enough to reveal what was hidden in plain sight. And if you think that blue flash is impressive, the next stone takes the effect to another level. Number 7. Labradorite. From the wrong angle, Labradorite can look like nothing. Gray, dark, dull. Then you turn it. Blue explodes across the surface, then green, gold, sometimes orange or violet. This is labradorescence. Light enters the stone and interacts with extremely thin internal layers. Those layers reflect different wavelengths of light back toward your eyes. The result is a sudden burst of color. A stone that looked lifeless seconds earlier can suddenly appear to contain an entire sky. Labradorite is found in several parts of the world, including Canada, Madagascar, and Finland. High-quality material is prized by collectors and lapidaries. But Labradorite's colors are only the beginning. The next stone can look as if thousands of tiny sparks are trapped inside. Number 6. Sunstone. Hold a good sunstone under the right light, and it can appear to glitter from within. Golden flashes, coppery sparks, reddish points of light. This effect is known as aventurescence. It is caused by microscopic reflective inclusions inside the stone. Tiny mineral particles catch the light and scatter it back toward your eyes. Depending on the variety, these inclusions may involve hematite or copper. Sunstone belongs to the feldspar family. Oregon is famous for producing gem-quality sunstones with rich, natural colors and strong sparkle. But the next gemstone did not begin as an ordinary mineral crystal. Its story began with a living creature in an ancient ocean. Number 5. Ammolite. Millions of years ago, ammonites lived in prehistoric seas. When they died, their shells were buried beneath layers of sediment. Most eventually disappeared, but under rare conditions, parts of some shells survived. And today, those ancient shells can flash with red, green, blue, and gold. This is Ammolite. Its spectacular colors come from microscopic layers within the ancient shell. As light reflects from those layers, different colors become visible. The angle changes, and the colors can change with it. Commercially important Ammolite is primarily found in Alberta, Canada, and the best specimens can be highly prized for the intensity and variety of their color. That means a flash of light inside a stone can sometimes reveal something extraordinary. A window into a prehistoric ocean. But the next mineral tells a completely different story. It may look dark and unremarkable, yet it helped change human civilization. Number 4. Cassiterite. Cassiterite is usually not famous for color. Many specimens look dark, heavy, almost industrial. But this mineral is the primary ore of tin, and tin changed human history. When ancient people combined tin with copper, they created bronze, a material that transformed tools and technology.
Cassiterite often forms in high-temperature geological environments associated with granite and hydrothermal systems. Mineral-rich fluids move through fractures, cool, and new crystals begin to grow. One of its most useful clues is weight. A small specimen can feel surprisingly heavy, and some exceptionally clear crystals can even be cut as gemstones. So, one mineral can be both an industrial resource and a collector's treasure. But the next stone proves that even the darkest mineral environments can create extraordinary brilliance. Number 3. Andradite Garnet. When most people think of garnet, they imagine red. Andradite can look completely different. Some varieties are nearly black, others are bright green. The most famous green variety is demantoid, and demantoid can produce exceptional brilliance and fire. Andradite often forms where heat, fluids, and changing chemistry transform existing rock. Over time, those conditions allow new minerals to crystallize. The result can be a gemstone with intense color and extraordinary sparkle. High-quality demantoid is especially prized by collectors, and that is why an ordinary-looking rock containing a small green crystal should never be judged too quickly. Because once that crystal catches the light, the entire appearance can change. And number 2 takes that changing color to another level. Number 2. Opal. Opal can look like a rainbow trapped inside stone. Red, green, blue, orange. The colors can flash, shift, and disappear as the viewing angle changes. This phenomenon is called play of color. Precious opal is made largely of tiny spheres of silica. When those microscopic spheres are arranged in the right structure, They interact with light and separate different wavelengths. That is what creates the moving fire inside the stone. It is not paint. It is not a surface coating. It is physics happening inside the material. Australia is famous for its important opal deposits. Ethiopia and Mexico also produce distinctive varieties. But not every opal displays this effect. Some are common opal, others are precious opal. And that difference can dramatically affect their appearance and value. But the number one stone does something even more remarkable. It can contain multiple colors inside a single crystal, each one recording a change that happened during its growth. Number 1. Elbaite Tourmaline. Pink, green, blue, yellow. Sometimes several colors inside one crystal. This is Elbaite, one of the most colorful members of the tourmaline family. One of its most famous varieties is watermelon tourmaline. A crystal can have a pink center surrounded by green. The pattern looks almost impossible, but it is a geological record. Elbaite grows from mineral-rich fluids. As the chemistry of those fluids changes, different elements enter the growing crystal. Those chemical changes can create different colors. One condition creates one color. The environment changes. A new color begins to grow. Over time, the crystal records those changes in visible layers. Elbaite is found in important gem-producing regions including Brazil, Afghanistan, Madagascar, Nigeria, and the United States. Exceptional crystals can be highly valuable, particularly when they combine intense color, clarity, size, and unusual color zoning. And that is why Elbaite earns the number one position. You are not simply looking at a beautiful crystal. You are looking at a visible record of changing conditions deep inside the earth. Final thought. So why does the title say, "If you see a rock shining like this, stop"? Because a sudden flash of color can mean there is more to the stone than its surface suggests. It might be common, it might be valuable, or it might reveal an extraordinary geological story. But you will never know if you walk past it without paying attention. Some shine because of oxidation, some because of microscopic crystal structures, some carry the remains of ancient life, and others preserve millions of years of changing chemistry inside a single crystal. So the next time sunlight catches a stone and something flashes back, stop, turn it slowly, change the angle, and see what the light reveals. Because sometimes, the story of a rock begins only when it starts to shine. Which of these stones surprised you the most? Peacock Ore, Labradorite, Ammolite, Opal, or Elbaite Tourmaline? And here's the question I really want you to answer. Which one of these stones would you most want to hold in your hand? Tell us in the comments. And if you have ever found a strange rock that looked ordinary, but revealed something incredible when the light hit it, tell us that story too. Subscribe to Pro Gems for more extraordinary discoveries hidden inside the natural world. Because sometimes, the most remarkable treasures on Earth are the ones people walk past without ever noticing.